Today let's discuss questions related to general equation of second degree. So the question 1 says that show that the equation this represents an elliptic paraboloid, and it also asks us to find the principal axis and the principal planes. So first let us just compare the given equation with the general equation. So if we do so the given equation to us is 2x square plus 3y square minus 8x plus 6y minus 12z plus 11 is equals to 0. So if we compare it with the general equation, we'll get basically a equals to 2, b equals to 3, c equals to 0, and since there is no term involving x, y, y, z and zx, so my f, g and h are 0, and my u is basically minus 4, v is 3 and w is minus 6, and the constant term d is 11. So first thing, while solving the general equation of second degree is you must find out the discriminating cubic and see what are the roots of it. That will give you a fair idea how to move ahead. So let's just find out the discriminating cubic, that is a minus lambda, b minus lambda, c minus lambda, f, g and h is equals to 0. So if I substitute values of the known terms here, I'll basically be getting a 2 minus lambda 0, 0, 0, 3 minus lambda 0, 0, 0 and minus lambda is equals to 0. Since it is in diagonal form, I can directly write out its discriminant. That would be 2 minus lambda 3 minus lambda is equals to 0. So my roots of discriminating cubic are basically 0, 2 and 3. So 0, 2, 3 are basically roots of my discriminating cubic. Also, if you observe that if you put lambda equals to 0 herein, you will be basically getting determinant as equals to 0. So this is of form d where d is equals to 0. So let us just move forward and let us just find out the direction ratios of side associated with lambda is equals to 0. So when my lambda is 0, so I can easily get direction ratios of associated axis. That would be basically 2l plus 0m plus 0n is equals to 0 and 0l plus 3m plus 0n is equals to 0. So if I solve it for lm and n, I'll be basically getting 0 minus m divided by 0 and n divided by 3 to the 6. So basically my direction ratios of axis associated with lambda equals to 0 is 0, 0, 1. I can divide throughout with 6 and this will reduce to 1. So my constant term k will be basically ul plus vm plus wn. That is my u is minus 4, l is 0, v is 3, m is 0 and w is I guess 6 minus 6 into n is 1. So I got my constant term k as minus 6. So my reduced equation is lambda 1 x square plus lambda 2 y square plus 2kz is equals to 0. And here lambda 1 and lambda 2 are basically the non-negative roots of discriminating cubic. So I got my equation, reduced equation as 2x square plus 3y square minus 12z is equals to 0. And if you observe that it is basically an equation of elliptic paraboloid. And in question it further asks us to find basically the principal axis and principal plane. So if I find, let's first find out the vertex. So basically vertex will be del f by del y is equals, del f by del x. So my vertex I can calculate using del f by del x divided by L, del f by del y divided by m equals to del f by del z divided by n is equals to 2 times k. So if I just substitute a value of known things, I'll be getting del f by del x is equals to 0. Del f by del y is also equals to 0 because my L and M are 0, and my del f by del z will be basically 2 into k is minus 6 and n is 1. So that is minus 12. So let's just solve these three equations and find out the vertex. So from my given equation is 2x square plus 3y square minus 8x plus 6y minus 12z plus 11 equals to 0. So from here if I calculate del f by del x, that is basically 4x minus 8 is equals to 0. So from here I got x as 2. Likewise, if I solve del f by del y, I'll be getting 6y plus 6 equals to 0. So from here I got my y as minus 1. And if I solve del f by del z, which is equals to minus 12, I'll be getting minus 12 into 1. Yeah, which is basically equals to minus 12 only. So I can take my z as 0. No. This, so I did not get any value of z from here, and there is another associated condition here that says k into lm plus k into lx plus my plus nz plus lu plus m it's plus lux plus vy plus wz plus d equals to 0. So let's just substitute value of lmn and uvw and the other terms in this equation and see what we get value of z as. So my k is minus 6, L is 0, so this terms reduces to 0, M is my 0 again, N is 1 and Z I am supposed to find, plus my U is basically minus 4 into X, that is 2, V is 3 into Y, that is minus 1, plus W is minus 6 and Z I am supposed to find, plus the constant term. So the constant term is 11. So if I put here constant term, this must be equals to 0. So this is basically minus 6z minus 8 minus 3 minus 6z plus 11 equals to 0, which is basically minus 12z equals to 0. So from here I got my z as 0. So my vertex is vertex of elliptic paraboloid is basically 2 comma minus 1 comma 0. So equation of principal axis. So equation of principal axis will be basically corresponding to lambda equals to 0. So equation of principal axis is basically x minus 2 by 0 equals to y plus 1 by 0 is equals to z minus 0 by 1. So this is basically my principal axis, and equation of principal planes is basically given by del f by del x equals to 0 and del f by del y equals to 0. So, and this we have calculated above as well. So del f by del x is x minus 2 is equals to 0 and del f by del y is y plus 1 is equals to 0. So these are basically the principal planes, and this basically represents the principal axis. So let's move on to next question. So the next question says that find the nature of quadratic surface of the given equation and also finds its associated characteristic principal axis and principal planes. So first let us just write the general given equation, that is 2x square plus 5y square plus 3z square minus 4x plus 20y minus 6z minus 5 equals to 0. So if I compare it with the general equation, I'll be getting a equals to 2, b equals to 5, c equals to 3, and since there is no term involving x, y, y, z and zx term, so my f, g and h are basically 0, and my u is minus 2, v is 10, z is minus 3 and d is minus 5. So let's just find out the discriminating cubic and see what its roots are. So if I just substitute, so I'll be getting 2 minus lambda, 5 minus lambda and 3 minus lambda, and f, g and h terms are basically 0. So from here I got my discriminating root as 2 minus lambda, 5 minus lambda, 3 minus lambda is equals to 0. So from here I got lambda as 2, 3, 5. So these are basically distinct roots. So equation can be either, the given quadratic surface can be either ellipsoid or hyperboloid in one sheet or hyperboloid in two sheet. So first let us just find out the coordinates of the center. So coordinates of center would be basically del f by del x equals to 0, del f by del y equals to 0 and del f by del z is equals to 0. So if I compare, I'll be getting 4x minus 4 equals to 0 and del f by del y will be 10y plus 20 is equals to 0 and 6z minus 6 equals to 0. So if I solve it, I'll be getting x equals to 1, y equals to minus 2 and z equals to 1. So basically my center of the given equation is 1, minus 2, 1. Now let's just find out the change the constant with respect to the center. That would be basically d dash, that is u x1 plus v y1 plus w z1. So this gives us, my u is basically minus 2 into x1 is 1, v is 10 into y1 is minus 2 and w is, this one is w is basically minus 3 and z1 is 1. So this is equals to minus 2 minus 20 minus 3, which is minus 25. So if we rotate axis, we'll be getting our reduced equation as lambda 1 x square plus lambda 2 y square plus lambda 3 z square plus d dash is equals to 0. So my lambda 1 is 2x square 3y square plus 5z square minus d dash, that is 25 equals to 0. So if I simplify it, I'll be getting 2x square by 25 plus 3y square by 25 plus 5z square by 25 is equals to 1. And this is basically an equation of ellipsoid. This is ellipsoid and its center is 1, minus 2, 1. Now let's just find out the direction ratios of axis and find out the equation of principal axes. So direction ratios can be find out if we get value of m and n here. So we can just solve these for specific values of lambda and we'll be getting 3 direction cosines. So let's just solve it for lambda equals to 2. So when lambda is equals to 2, the first equation will basically be 0 only. So we'll be solving the below two equations. So if we substitute lambda equals to 2 here, so I'll be getting 2 into 0 into L plus 3 into M plus 0 into N is equals to 0, and 0 into L plus 0 into M plus 1 into N is equals to 0. So if I solve it, I'll be getting L by 3 is equals to minus M by 0, which is equals to N by 0. So my direction ratios with this when my for lambda equals to 2 is basically 3, 0, 0. So principal axis from for lambda equals to 2 will be basically x minus 1 by 3 is equals to y plus 2 by 0 is equals to z minus 1 by 0. Likewise, we can find out for lambda equals to 3. So for lambda equals to 3, it will be basically minus L plus 0m plus 0n is equals to 0, 0L plus 2m plus 0n is equals to 0. So if I solve it for L, M and N, I'll be getting 0 minus m by 0 and n by minus 2. So my equation of axis when lambda is equals to 3 is basically x minus 1 by 0, y plus 2 by 0 and z minus 1 by minus 2. Likewise, for lambda is equals to 5, it will be minus 3L plus 0M plus 0N is equals to 0 and 0L 0M plus minus 2 into N is equals to 0. So if I solve it for L, M and N, I'll be getting 0 minus M upon 6 and N upon 0. So if I solve it, I'll be getting 0 minus comma and 0 as direction ratios of line with respect to z axis. That will be basically x minus 1 by 0, y plus 2 by minus 6, or if we can divide it throughout by minus 6, so we'll be getting 1 is equals to z minus 1 by 0. So these are the three principal axes with respect to lambda equals to 1, lambda equals to 2 and lambda equals to 3. And equation of principal planes will be, so we can find out using lambda into Lx plus My plus Nz plus Ul plus Vm plus Wn is equals to 0. So my when my lambda is 2, my m and n are 0, so 2 into x into L, that I can write as 1 plus m and n are 0, so and my u is basically minus 2 into 1. So if I solve it, I'll be getting my plane as x minus 1 equals to 0. So and when my lambda is 3, my Lm and are 0, so it is 1 into z plus my w is basically minus 3 into 1 is equals to 0. So z plus 1 is equals to 0 is z minus 1 equals to 0 is the principal plane when my lambda is 3. Likewise, when my lambda is 5, then L and N are 0 and M is 1, so 1 into y plus my V is 10, so 10 into 1 is equals to 0. So y plus 2 is equals to 0 is basically my third plane when my lambda is 5. So that's all we are asked in this question. Now let's move on to next question. So the next question says that reduce this equation to canonical form and mention the name of the surface it represents. So the given equation is 3x square minus y square minus z square plus 6yz minus 6x plus 6y plus 2z plus 2 equals to 0. So if I compare it with general equation, I'll be getting a as 3, b as minus 1, c as minus 1, f as 3, g and h are basically 0 because there is no term with x, y and xz, and my u is minus 3, v is 3, and z w is 1, and my constant term d is 2. So let's just find out the discriminating cubic first. So discriminating cubic is 3 minus lambda 0 0 0 minus 1 minus lambda, f is 3 0 3, and minus 1 minus lambda is equals to 0. So if I solve it, I'll be getting 3 minus lambda into 1 plus lambda square minus 3 square is equals to 0. So if I simplify it, I'll be getting 3 minus lambda into 1 plus lambda plus 3 into 1 plus lambda minus 3 is equals to 0. So from here I will be getting lambda as 3 minus 4 and 2. So these are my 3 roots of discriminating cubic, and all 3 roots are distinct. So the general equation of cubic can be either ellipsoid or hyperboloid in one sheet, or maybe hyperboloid in two sheet, or a cone, depending on the changed constant. So for that, let's just find out the center of the equation. So center coordinates of center can be find out using del f by del x equals to 0, del f by del y equals to 0, and del f by del z is equals to 0. So if I find out del f by del x from this equation, I'll be getting 6x minus 6 equals to 0. Del f by del y will be minus 2y plus 6z plus 6 equals to 0, and del f by del z is basically minus 2z plus 6y plus 2 equals to 0. So if I solve it, I'll be getting x equals to 1 and minus y plus 3z plus 3 equals to 0, and third equation is basically 3y minus z plus 1 equals to 0. Now I can solve these two equations to get value of y and z coordinate of the center. So from this one, I'll be getting y is equals to 3z plus 3. Let's just substitute this value of y here. So it is 3 into 3z plus 3 minus z plus 1 equals to 0, which basically gives me 9z plus 9 minus z plus 1 equals to 0. From here I'll get 8z plus 10 equals to 0. So from here z is equals to minus 5 by 4. And if I just substitute this value of z here, I'll be getting y equals to 3 minus 3 into 5 by 4, which basically gives me 12 minus 15 by 4. So my y is minus 3 by 4. Minus 3 by 4. So my center is basically 1 comma minus 3 by 4 comma minus 4 by 4. Now let's see what will be the constant term when we rotate the axis. So that is basically ux1 vy1 plus wz1 plus t, and my u is minus 3 into 1, v is 3, and w is basically 1, I guess. Yeah, v is 3 and y1 is minus 3 by 4, w is 1, z1 is minus 5 by 4, plus constant term d is 2. So this basically gives you minus 3 minus 9 by 4 minus 5 by 4 plus 2, which is minus 1 minus 14 by 4, which is basically minus 18 by 4. So my reduced equation is basically 3x square plus 2y square minus 4z square minus 18 by 4 is equals to 0. So this is 3x square plus 2y square minus 4z square is equals to 18 by 4. So this represents basically hyperboloid in one sheet. Hyperboloid in one sheet. So let's see the next question. So the next question says that reduce the following equation to standard form and hence determine the nature of conicoid. So the given conicoid is this. So it is x square plus y square plus z square minus yz minus zx minus xy minus 3x minus 6y minus z plus 21 is equals to 0. So if I compare it with general equation, I'll be getting a is equals to 1, b and c are also 1, and my f is basically minus 1 by 2, g is also minus 1 by 2, and h is also minus 1 by 2. Likewise, my u is basically minus 3 by 2, v is minus 6, and w is minus 9 by 2, and my constant term d is 21. So first let us just find the discriminating cubic, that is basically a minus lambda, c minus lambda, and f, h and g is equals to 0. So if I substitute value of known things here, I'll be getting 1 minus lambda minus 1 by 2 minus 1 by 2 minus 1 by 2 1 minus lambda minus 1 by 2 minus 1 by 2 minus 1 by 2 and 1 minus lambda is equals to 0. So if I solve it, I'll be getting 1 minus lambda into 1 minus lambda whole square minus 1 by 4 plus 1 by 2 into minus 1 by 2 into 1 minus lambda minus 1 by 4 minus 1 by 2 into 1 by 4 plus 1 by 2 into 1 minus lambda is equals to 0. So if I simplify it, I'll be getting 1 minus lambda cube minus 1 by 4 into 1 minus lambda minus 1 by 4 into 1 minus lambda minus 1 by 8 minus 1 by 8 minus 1 by 4 into 1 minus lambda is equals to 0, which basically gives me 1 minus lambda cube minus 3 by 4 into 1 minus lambda minus 1 by 4 is equals to 0, which is equals to 4 into 1 minus lambda cube minus 3 lambda plus 3 lambda square minus 3 plus 3 lambda minus 1 is equals to 0, which on simplifying is equals to minus 4 lambda cube plus 12 lambda square and 4 3s are minus 12 plus 3 minus 9 lambda, and constant term is 4 minus 4, which is 0. So from here I'll be getting lambda into minus 4 lambda square plus 12 lambda minus 9 is equals to 0. So my roots are basically lambda is equals to 0 and lambda equals to and lambda 4 lambda square minus 12 lambda plus 9 is equals to 0. If I solve it, I'll be getting lambda as 12 plus minus under root b square, that is minus 12 square minus 4 into 4 into 9 divided by 2 into 2a. So I got my lambda as 12 plus minus under root 144 minus 16 into 9, that is 144 only, divided by 8. So I got my other two lambdas as 12 by 8, that is basically 3 by 2. So my roots of discriminating cubic are 0, 3 by 2, 3 by 2. So here one root is basically same 0 and other two roots are same. So let's just find out the direction cosines of axis with respect to lambda is equals to 0. So when my lambda is 0, so direction ratios of axis would be basically L minus m by 2, L minus m by 2 minus n by 2 is equals to 0, and minus L by 2 plus m minus n by 2 is equals to 0. So let's just solve this for L, m and n by cross multiplication method. So I'll be getting 1 by 4 plus 1 by 2, that is basically 3 by 4, and m is minus 1 by 2 minus 1 by 4, that is minus 3 by 4, and n is 1 minus 1 by 4, that again gives me 3 by 4. So if I divide throughout by 3 by 4, I'll be getting direction ratios as 1, 1, 1. So now let's just find out the constant term k, that is basically k equals to ul plus vm plus wn, that is my u, v and w are minus 3 by 2, minus 6 and minus 9 by 2, minus 3 by 2 plus minus 6 and plus minus 9 by 2 into 1. This basically gives you minus 3 by 2 minus 9 by 2 minus 6, which is minus minus 3 and minus 12 by 2. This is minus 12, which is not equals to 0. So my reduced equation is basically 3 by 2 x square plus 3 by 2 y square minus 12 in minus 2k. So 12 into 2z is equals to 0. So if I simplify it, it is basically x square plus y square minus 24z into 2 by 3 equals to 0, which basically gives me x square plus y square minus 16z is equals to 0. So this is basically equation of elliptic paraboloid. Elliptic paraboloid. So the given general equation represents elliptic paraboloid. So let's now move on to next question. So the next question says that reduce the following equation to its canonical form and determine the nature of the conic. So the equation is 4x square plus 4xy plus y square minus 12x minus 6y plus 5 equals to 0. So if I compare it with general equation, I'll be getting a as 4, b as 1, c as 0, f as 0, g as 0 and h as 2. And my u is basically minus 6, v is minus 3, w is 0 and d is basically 5. So my discriminating cubic will be basically 4 minus lambda, 1 minus lambda, 0 minus lambda, 0, 0, 0, 0 and 2, which must be equals to 0. So if I solve it, I'll be getting minus lambda into 1 minus lambda into 4 minus lambda minus 4 equals to 0, which basically gives me minus lambda into 4 minus 4 lambda minus lambda plus lambda square minus 4 equals to 0. So from here I got my lambda equals to 0 and lambda square minus 5 lambda equals to 0, which basically gives me lambda equals to 0, 0, 5 as roots of discriminating cubic. So here two roots are 0, and 1 is 5. So let's further verify this condition, that is AU that is fu, which is basically fu is f into u is 0, gv is again 0, and hw, which is also 0. So which says that fu is equals to gv is equals to hw. So if any discriminating cubic has two roots at 0 and also satisfied this equation, then the given equation represents basically equation of planes. And if you observe that the given equation is basically 4x square plus 4xy plus y square minus 12x minus 6y plus 5 equals to 0. So I can write this equation as 2x plus y whole square. This thing forms 2x plus y whole square, and I can take 6 common from here. So it will be again 2x plus y plus 5 equals to 0. And if you observe that this equation becomes basically a quadratic equation in 2x plus y. So let us assume that 2x plus y is equals to capital X, let's say. So the equation will be reduced to capital X square minus 6 capital X plus 5 equals to 0. And I can solve it for capital X. So that will be capital X square minus x minus 5x plus 5 equals to 0. So this basically gives me capital X minus 1 and capital X minus 5 equals to 0. So from here I got my capital X as 1, 5. And I have assumed my capital X as 2x plus y. So it is 2x plus y is equals to 1 and 2x plus y is equals to 5. So, and if you observe that these are basically the parallel planes. So the given equation represents a parallel plane equation. Now let's move on to next question. So the next question says that reduce the equation into canonical form and determine its nature of quadratic. So let's just compare it with a general equation of cubic. So the general equation, my given equation is basically 2y square minus 2xy minus 2yz plus 2zx minus x minus 2y plus 3z minus 2 equals to 0. So if I compare it with general equation, I will be getting a equals to 0, b equals to 2, c equals to 0, f is minus 1, g is 1 and h is also minus 1, u is basically minus 1 by 2, v is minus 1 and w is 3 by 2, and constant term d is minus 2. So let's just find out the discriminating cubic, that is 0 minus lambda, h is minus 1, g is 1, minus 1, 2 minus lambda and f is minus 1, 0 minus lambda, 1 equals to 0. So if I solve it, I'll be getting minus lambda into 2 minus lambda minus 1 plus lambda plus 1 plus 1 into 1 minus 2 minus lambda is equals to 0. So if I solve it, I'll be getting minus lambda into minus 2 lambda plus lambda square minus 1 plus lambda plus 1 plus lambda minus 1 is equals to 0. And if I solve it further, it will reduce to 2 lambda square minus lambda cube plus lambda plus 2 lambda is equals to 0. So this basically gives me minus lambda cube plus 2 lambda square plus 3 lambda is equals to 0. So from here I will be getting roots as, I can take lambda as common and equation will reduce to minus lambda square plus 2 lambda plus 3 is equals to 0, which gives me lambda is equals to 0 and lambda square minus 2 lambda minus 3 equals to 0. And if I solve it, I'll be getting lambda is 2 plus minus under root b square, that is 4 minus 4 into minus 3 by 2, which basically gives me lambda as 2 plus minus under root 4 plus 12 16 by 2. So it is 2 plus minus 4 by 2, which is basically 6 by 2, that is 3, and minus 2 by 2, that is minus 1. So my roots of discriminating cubic are 0, 3, minus 1. Now let's just find out direction ratios of axis when lambda is 0. So when lambda is 0, so the direction ratios will be basically 0 into L minus m plus n is equals to 0 minus L plus 2m minus n equals to 0 and L minus m plus 0 n equals to 0. So if I solve any two equations, I'll be getting, so from let's just solve first and third equation. So from there I'll be getting m equals to n and L equals to m. So that basically gives me direction ratios as L equals to m equals to n. So my direction ratios are basically 1, 1, 1. Let's further find out center of the conic. So that will be basically del f by del x equals to 0, del f by del y equals to 0, and del f by del z is equals to 0. So if I solve it, del f by del x will be basically minus 2y plus 2z minus 1. It is minus 2y plus 2z minus 1 equals to 0. Del f by del y will be 4y minus 2x minus 2z minus 2. It is 4y minus 2x minus 2z minus 2 equals to 0. And del f by del z would be basically minus 2y plus 2x plus 3. Minus 2y plus 2x plus 3 equals to 0. And now I can solve these values for x, y and z. That would basically give me, so from here my 2y is basically 2x plus 3, and from here my 2y is 2z minus 1. So if I compare these, I'll be getting 2z minus 1 equals to 2x plus 3, which basically reduces to z is equals to x plus 2. So if I just substitute these values of x, y and z here, and let's see what we get. So 4y minus 2x minus 2 into z, that is x plus 2 minus 2 equals to 0, and my y is basically 2y is basically 2 into 2x plus 3 minus 2x minus 2x minus 4 minus 2 equals to 0, which basically reduces to, this doesn't lead anywhere, it just satisfies the equation. So let's see what else we can do. So basically my x, y and z are, my x is 2y minus 3 by 2 and y, and my z is basically 2y plus 1 by 2. So if I choose my, let's say y equals to 0, so I'll be getting center as minus 3 by 2 comma 0 comma 1 by 2, and it is one of the centers. So let's just find out k. That will be basically u alpha plus p beta plus w gamma, if I name it as alpha comma beta comma gamma, and u is minus 1 by 2, alpha is minus 3 by 2, v is minus 1, beta is 0, and w is 3 by 2 and gamma is 1 by 2. So if I solve it, I'll be getting 3 by 4 plus 3 by 4, which basically gives me 3 by 2. So the given equation basically can be reduced in canonical form as lambda 1x square plus lambda 2y square is equals to k, which basically gives 3x square minus y square is equals to 3 by 2, and it's basically a hyperbolic cylinder. To prove this, you also need to verify certain conditions, certain more conditions as well, that is AU plus BV plus CW, that must also be equals to, that you also need to verify this condition, and A, B and C must be non-zero as well. So you can verify this as well, this will be satisfied, and you can reduce it to this hyperbolic cylinder. So thank you for watching. This is the last question of this topic.